Swayam Prabha. Digital India. Educated India.
Welcome back to the course Mechanics of Solids. So, in the last lecture we are talking about the plane truss and different say details of the plane truss, and we have seen in the last lecture that how you can find out or how you can determine the rigidity of the truss, how you can calculate or how you can check whether the truss is rigid or not, and then finally we have seen that whether the truss is statically indeterminate or not. Statically indeterminate will be having two components, one is externally determinate or internally determinate. So, those things we have seen in the last lecture. So, now in this particular lecture we will be talking about the solution of plane truss, that means how we can solve or how we can analyze the plane truss system, solution of plane truss. So, there are two methods by which we can solve or analyze the plane truss. First one is method of joints. So, we have a little bit discussed about this thing in the last lecture, if you recall, method of joints, and second is method of sections. Okay. Now, we will be coming one by one. So, first we will be discussing about method of joints. So, what we do here, whatever, and of course, at this moment we are not going to analyze any internally indeterminate truss, because whatever truss we will be discussing in this particular chapter, everything will be internally determinate truss. So, if you want to analyze the internally indeterminate truss, then basically you need some other logic or some other conditions, okay? Otherwise you cannot solve the indeterminate structure. That is very simple. I mean, as we discussed in the last lecture or last to last lecture, when we are talking about the determinate and indeterminate structure. So, for the time being we are only discussing with or these methods, method of joints and method of sections, we are just applying on the internally determinate as well as the externally determinate truss. Okay. So, now in this method basically suppose you have a truss like that, a load is applied F1 here, another load is applied here, these are all joints, these are all joints, this is your C point, A, B, T. At A you have hinge support, at D you have ruler support, and at C you have a force F2. Okay. So, this is the truss. Now, first, what is your first job? So, first job is to draw the free body diagram of the whole truss. So, if you want to draw the free body diagram of the whole truss, so what is your first job? You remove the system, that means you are replacing the supports by corresponding support reactions AY, AX and dy, where x and y are like this. Okay. So, this is your free body diagram of the truss. Now, what are the things you need to check? First you check whether this truss is externally determinate or not. That means whether you can manage to calculate or determine the support reactions, right, and that you can find out, right. So, how many support reactions you have? Ax, Ay and dy. So, you have 3 unknowns. How many equations of equilibrium you are having with you? 3 equations, summation of Fx equal to 0, summation of Fy equal to 0 and summation of moment equal to 0. So, 3 equations, 3 unknowns. So, you can find out those unknowns. So, therefore, this is externally determinate system. Okay. Now, it is also statically or the internally determinate, and you can check it, because if it is not internally determinate, then you cannot find out all the member forces, and we will see that all the member forces can be obtained, okay, by using your equations of equilibrium. So, therefore, it is internally determinate structure. Whether it is rigid or not, so you just check it. How many joints are there? 1, 2, 3, 4. There are 4 joints. To get just rigid truss, how many members you need? 4 joints means 2 into 4 minus 3. So, 5 members, minimum members 5 will be required to get the just rigid structure. So, how many members are there? 1, 2, 3, 4, 5. So, therefore, this is a just rigid truss. So, all those check we have done before analyzing the problem. Now, in method of joints, what we do? We consider each and every joint, okay, and we try to satisfy the equations of equilibrium available with me at each and every joint, okay, and in that way we proceed for the whole truss to get the unknown member forces. Now, what does it mean? Now, let us talk about the free body diagram of joint A. So, this is your joint A. So, when I am talking about joint A, how many equations of equilibrium available with me? 2, because moment equilibrium moment equation will be giving me the trivial solution, because if I take the moment with respect to point A, of course, the moment of all the forces will be 0, right. Whatever forces are getting converged or whatever forces are getting emerged from point A, basically the moment will be all the forces will be 0. So, that is not serving my purpose. So, 2 equations of equilibrium are available with me, that is summation of Fx equal to 0, that means all the forces, summation of all the forces along x direction is 0, summation of all the forces along y direction is 0. So, these two equations are available with me. So, if there are 2 equations are available with me, equations of equilibrium, then how many unknowns I can solve? 2. If there are 3 unknowns at a particular joint, then you will not be able to solve it. So, that will become the statically or internally indeterminate structure. So, now if you consider joint A, what are the forces are acting? This is your AY. Now, it is known from our analysis AX, that is also known. So, before jumping on the actual truss problem or the calculation of the member forces, you need to know the support reaction. So, AX and AY both are known, right. Now, what are the things are unknown? So, let us draw that thing in different color. So, unknown is member force, because AB is a member, and already we have decided that all the members are 2 force members. So, therefore, the line of action of the member force will be along the axis of the member, there is no doubt. So, the line of action of member force AB will be along the line AB. So, that I am showing FAB, and What is the other member which is emerging from point joint A? That is AC. So, FAC. So, you have two known parameters AX and AY. You have two unknown parameters FAB and FAC, and two equations of equilibrium available with you. So, conceptually you can get these values just by using your vectorial analysis, right, by just doing your vectorial analysis, whatever you have seen earlier in your 10+2 physics class or something like that. Just by following the vectorial analysis, you will be getting the member force FAB and FAC, right. Now, I have shown AY vertically upward direction, AX from left to right. The same thing I am showing here, because I do not know whether it will be left to right or right to left, AX will be left to right or right to left, I do not know. Whether AY will be vertically upward or downward, I do not know. That will be dependent on the calculations, or that will be dependent on the magnitude, right. For the sake of say completeness, we are assuming that AX is acting vertically upward direction and AY is acting vertically upward direction and AX is acting from left to right. But I have shown FAB in this direction, which is coming out from joint A. Similarly, FAC in this direction, that is also coming out from joint A. Now, who told me that it will be coming out from joint A? It could be towards joint A, yes or no? Because I do not know, I have not calculated. And before calculation or before obtaining these values, who are telling me that this should be coming out or coming in, right? The direction of FAB is completely unknown to me, because I do not know the magnitude, I do not know the direction of FAB, only I know the line of action of the force, right. So, now for understanding or for how you will select the direction, let us discuss one thing. Now, I am considering two members, two truss members. Okay? This is member 1 and this is another member 2 say. So, this is the free body of the member 1, this is the free body of member 2. These are the free bodies of joints which are connected at each end of the members. Okay. So, now if I say this member is under compression, because as already we have decided that these members can only take axial force, that is the two force members, that means axial force only is applicable, it could be tension or compression. Say for example, this member is taking compression. If this member is taking compression, then what should be the direction of force? This should be the direction of force, compressive force, say that is C. If the force is compressive on the member and if the direction of the force is like this, then from our previous discussion, what will be the direction of force on the joint, just equal and opposite. This will be the direction of force on the joint. Agreed? So, no doubt. Okay. Now, I am saying this member is under tension. So, this is my tension force. So, this should be the direction of tensile force. If the member is under tension, that will be the direction of the axial force. So, on the joint it will be giving equal and opposite force. Now, what you have understood from this? If the member is under compression, that means for compression member, the arrow, the force, okay, is, if the member is under compression, then the force will be acting towards the joint. You just see here, it is acting towards the joint, that means it is pointing towards the joint, it is coming in. If the member is under tension, then what will be the direction of force on the joint? It will be coming out from the joint, right? It will be coming out from the joint. Now, you come to this part. What I have shown, FAB and FAC both are coming out from joint. Then what we are assuming, because I do not know the force in member AB and member AC. So, what we are assuming? We are assuming that the forces in both the members, member AB and member AC, are tensile in nature. Nobody told me, I just assumed. Okay? I just considered that these forces are tensile in nature, and it is always advisable to stick to a particular assumption. What is that particular assumption? That you consider that all the member forces are tension or all the member forces are compression. Do not scratch your head, oh, this force will be compressive or this force will be tensile or what will be like that. Do not get confused there. It will be coming automatically. Okay. So, what I mean to say, you consider all the member forces are tensile in nature or all the member forces are compressive in nature. Now, in the calculation or in the analysis, in the process of analysis, if they are coming opposite sign, then that whatever direction you consider, that is not the right thing. For example, now after calculation, if I get FAB equal to minus of something, then of course, I will be understanding that whatever direction of FAB I consider, that means we considered FAB was tensile in nature. That is not true. If it is coming negative, that should be compressive in nature. Similarly, if FAC whatever direction you considered and finally you have got FAC equal to some value, positive value, then of course, whatever direction you assumed or considered before the analysis, that was correct. So, what I mean to say, do not spend any time in deciding what should be the probable, say, nature of the force in individual member. It will be coming automatically. Okay? So, do not, I mean, you just stick to the basic. You consider all the forces tensile or all the forces compressive, or you can mix up. Though it is not advisable, you can mix up. If you consider compressive, suppose if I consider FAC compressive, that means it is coming towards the joint, and ultimately if I get negative value of FAC, then that means the compressive nature whatever I assumed, that is not correct, right. So, you just stick to a particular thing, and whatever things are coming automatically in the process of analysis, you just follow that. Okay. Now, so by considering the equilibrium of joint A, we have virtually or conceptually or philosophically, we can say that we will be getting the magnitude of F A B and A C, because we have two equations, two unknowns, we can solve it. Now, after point A, okay, if you go to point B or point C, whatever you want, say point B I am going. Let's draw the free body diagram of joint B. How it will look like? So, this is your joint B. Okay. What are the forces are coming out? So, I am going to show the known forces in white color and unknown forces in red color. Okay. That is my convention we are using. Say what are the forces are coming out from joint A? So, joint A is basically formed with three members connection, member AB, member BC and member BD. So, they are connected at joint B, right, they are connected at joint B. So, this is now my known force FAB, because if I consider joint A and if I solve joint A, basically this force is known to me now, that red color has been transformed to the white color because it is known to me, and this is the externally applied force F1 at joint B. Now, what are the unknown forces at joint B? FBC and FBD. So, these two are unknown forces at joint B. Again we have two equations, summation of Fx equal to 0, summation of Fy equal to 0. So, two equations, two unknowns, again we can solve it. Now, after solving joint B, we are moving to joint C. This is my joint C. So, at joint C, what are the member forces are acting? Member AC, member BC, member CD. Now, member AC is known to me, right? Member AC is known to me when I consider joint A. Member BC is also known to me because I just consider joint B. And this is the externally applied force, it is of course known to you. Now, what is unknown to you? Your unknown force is only FCD. Right, that is the only unknown force. Now, if you look at, if you want to exploit or if you want to satisfy the equation for equilibrium, that means only summation of Fx equal to 0 will give you the value of FCD, and from this configuration it is very much clear that FCD must be equal to FAC, equal and opposite, right. Now, we will come to, so which member force is left out? BD is not known to me, other forces in different members we have already got it. So, BD is not known to me. So, for BD we will be considering joint D. So, this is my joint D. At joint D you have dy which is known to you. You have CD, you have just came across when we considered joint C, we have got FCD. Now, only unknown force is, oh no, even FBD is known to you, right. So, from this, when we considered joint B, you calculated BD also. But anyway, for the sake of check, you can consider joint D, and again you can find out if BD, and you will see you will be getting the same value whatever you have got when you consider joint B. So, in this process, by considering each and every joint, by moving from the joint A, you have considered different joints and you have got the member forces, right. So, this method is known as method of joints. Okay. So, I will stop here today. In the next lecture, we will be talking about the method of sections, and then we will be moving to the friction part. Okay. Thank you very much.